I pressed go live. But
Oh, no problem, no problem. No. You can go live.
Right.
What is an error function? Reparameterization of a curve. Which is the book which I referred to prepare for mathematics competition. Types of calculus. There are two types.
Yes.
I want to learning calculus. Will the questions be direct or slightly twisted? Xn equals a sequence, then modulus of xn is less than or equal to 1 and it is not convergent. Why? What sort of question is this? What type of question will count only as a main test, objective, subjective, or both? This is a question you are supposed to ask.
Like in case meaningless question, you can skip some.
See, let me go on answering.
Right.
Himanshu Shekhar, what is an error function? So where did you get this term error function?
But we don't know.
Error function, for example, if you want to integrate, if I have taught you numerical integration, then don't we had numerical integration, right?
Yes.
So when you have numerical integration, means we are not integrating a function exactly, we are using some numerical techniques to give an approximate answer. Then what happens is that this approximate answer, the difference between the approximate answer and the real, the exact analytical answer, which we have not computed, that difference is the error function. It changes with the level of approximation you make. It is sufficient. Second question, it is sufficient for preparing IIT JAM portion of function of one variable. Of course, it is sufficient for doing any preparation. But I think this forum is, I want to make something very clear that this forum is not really meant for me answering these questions, whether this course is fit for JAM or this course is fit for something else. This was a course which was given with details whose main idea is to give you the concepts of calculus so that you can learn and use them when you actually use them. It has to depend on how you use them. Okay. Somebody called Hussein Kanchawala, who is asking, is calculus used in finance, especially algorithmic trading, investing? Calculus is of course used in finance, but the calculus that you use in finance are tools of calculus, because finance largely deals with probabilistic techniques and also called stochastic processes, and also uses a technique called optimization where calculus is used. But it is not that you would just use you really just do some differentiation or integration. Calculus involves all those, or finance involves all those processes of differentiation and integration. Calculus is used, but as a tool. Please understand that. Which book I referred to preparation for mathematics competition? This is not a good question to ask me, because I am not here to tell you which book is you supposed to prepare from, because book is of course your choice. A book cannot be, a book doesn't depend on what if I have to tell you about a book, I can show you a book called Calculus for the Ambitious. Here I am putting it up. Calculus for the Ambitious by T.W. Corner. It's a Cambridge University publication. If somebody wants to really learn calculus, enjoy the subject, then I think this is a very good book to go through. You can just keep it in a bag and move around, and this is the kind of thing which you wouldn't. This is the kind of thing which is written by one of the finest mathematicians on earth. So see, it's all I'm telling you. This when I'm giving a course here, my intention is to teach you, is to tell you the excitement of the subject, convey to you the conceptual issues about the subject. It's never it is never to tell you that okay, I am here to prepare you for some competitive exam, some jam or some gate or some whatever. This is not what I am trying to prepare you for here. I am trying to prepare, make you conceptually strong so that you understand calculus better and you can use it. I think the questions Pulkit has asked, what type of questions will come on 29 September main test? Objective or subjective or both? I think it's objective only.
Yeah, MCQ.
It's all MCQ questions. There's no subjective question. No. And another by Anju CP, I do not understand your question. Xn be the sequence and modulus of Xn is less than or equal to 1 and it is not convergent. Why? I do not understand this question. Why if a sequence is Xn, why modulus of Xn should be less than equal to 1? I don't have any. So if you are talking about a sequence called Xn is -1 plus 1. Okay, yeah. So what I'm trying to tell you, I think this is an example I'm trying to give you. It's called bounded sequence. Bounded sequences may not be convergent. That is, I take a sequence of the form this +1 -1. I alternate. So any xn, the nth term, can be given as or maybe I will write it like this: -1 plus 1. That will be easy for me to write. -1 to the power n. So xn is given in this form. Okay, xn is a sequence. Every sequence is given. So when n is 1, it is -1. When n is 2, it is +1, and so on and so forth. What I am trying to say is that modulus of xn here. What is modulus of xn? Is 1. If you take the mod of any value here, the absolute value, it is 1. But this sequence is not convergent because there is no one particular value where the sequence goes. It always oscillates between +1 and -1. So this sequence that you see here is not convergent. It is not going to infinity either. These kind of sequences are called oscillatory. They're divergent, but divergent in oscillatory way.
Sir, one question is KH integral important? Rajushree Chatterjee.
That's a very good question. KH integral is gradually getting important. KH integral was initially thought as not a match to Lebesgue integral, but it does integrate those functions which Lebesgue integral can integrate. But Lebesgue integral, the machinery associated with Lebesgue integral can be intimidating sometimes because of the idea of measure. Though it's beautiful mathematically, but it can be intimidating. But in order to stop that kind of feeling, get that kind of feeling, learning KH integral is a very good exercise. People can say, okay, in reality, in real practice, we really need to bother about Lebesgue integral unless I'm doing mathematical research. I can just in real practice, I have integral, I can put it in a integral if I want to compute it. There are so many numerical softwares, I can put them and get the answer. But that's not the issue. The issue is that whether the idea of Riemann can go forward. But KH integral is gradually becoming more and more popular. There are full courses being given on KH integral. So the Lebesgue idea caught over because the Riemann integral was becoming popular quite for some time because there was Newton's idea of integrating a continuous function. Then Riemann took it to bounded function. Then he brought it to bounded measurable function. So why Lebesgue's idea was interesting because he had taken a very different way. He partitioned the y-axis instead of the x-axis. But this Kurzweil-Henstock integration, you actually have to partition only the x-axis, but the controlling that partitioning parameter, that has to be changed. The delta fine partition, the whole idea of partitioning changes a bit. So if you just change the idea of partitioning without bothering about measures and all, measure theory and all those things, you can actually get into full-fledged integration theory. And people have been, there have been people who are actually building up the KH integral theory in much more detail, and they are being taught as full courses, and books are appearing on KH integrals quite frequently nowadays. So KH integrals is gaining popularity. In fact, many of you must have heard this name, this book by recall Real Analysis by Bartley and Shepard. Bartley has spent a lot of time of his career writing a full book on KH integration, which is called Modern Theory of Integration. And there are very latest books. There is a book on, this year there is a book which is published on KH integral. So KH integral is gaining importance. What I wanted to show you, that things which cannot be integrated in Riemann integration can be integrated by using KH integral. So KH integral is a theory which has almost a similar power like Lebesgue theory. So we want to, the Lebesgue integral has become an official integral, and people are so comfortable using Lebesgue integration that people do not want to get into a new kind of theory again.
Sir, Hussein has asked, can you suggest some good software to practice and learn calculus?
I can't suggest any. You don't learn calculus by doing using softwares. How do you understand the inner meaning of things if you use softwares? There are softwares like I should have then bought my calculator. Nowadays you have Casio calculators where you can actually integrate. You can symbolically integrate, or you take a software like Maple, or Mathematica. What they use is called computer algebra. So these are called symbolic. They can do symbolic calculation. So if in Maple or Mathematica, if you give an integral like this, and you give the limits from 0 to 1, they will give you the answer 1/3. And if you even just write say x squared dx, just integrate, they will give you the answer x cubed by 3 plus a constant. Can Simpson rule give exact integration values? In general, no. In very particular simple cases, might be yes. One needs to check it. In general, no. It's an integration. It's a kind of approximation that we are trying for the integration values. In general, Simpson's rule cannot give you exact integration values. If it gives me the exact value, then I need not study its error function, error analysis.
Quadratic polynomials, it can give exact value. Sir, quadratic polynomial can.
So a very specific case, only very specific. If you take x square, if you integrate over x square from 0 to 1, it will give. I'm talking about, but I'm not, see, you don't do numerical integration when you have the very simple issues. You do numerical integration when it is very difficult to integrate. For example, if I tell you to integrate like a very complex function involving trigonometric function, exponential function, etc., to write an analytical formula is very difficult, then you integrate numerically. You don't integrate very simple quadratic functions, you will get, but you need to do that number of, you need to have the number of partitioning this. When you do this integrals, you have to take, it cannot be done, you just take 2. So you are doing x square, for example, if you want to integrate from 0 to 1, So if you just make two boxes, things like this. This is what you're doing. Basically you're approximating the limiting process. Then you don't get an exact answer. So you have to increase the number of boxes and you have to, in a limiting form, you will get the answer. But exact answer, except very simple toy examples, you cannot get. No, it's not possible. How can one be well versed with the analytical approach of calculus? Mr. Amit Kumar has asked, as we are more familiar with its application. I do not understand how you can apply a thing whether if you do not know uh, about its basic analysis. I'm talking not about its deeper analysis. I mean, its deeper analysis of issues in calculus gives a subject called real analysis. But you have to understand what is the sequence. You have to know what is a derivative. I want to tell you there is a very famous saying by Benoit Mandelbrot, and Benoit Mandelbrot was a person who invented fractals. That you would understand calculus. He told it in an interview with the with a team from Mathematical Association of America, that you will understand calculus much better if you know at the very outset that every continuous function did not have a derivative. Like fx is equal to the absolute value of x, a continuous function but does not have a derivative at 0. And you will also understand, and I would add to that and try to say that you will also understand calculus much better if you know at the very outset that derivatives and integrals are names given to some special kind of limits. Those who want to understand the analytical issues deeply, I want to suggest for them a book. I want to suggest for them a book which has been published this year, a book which is much more lighter to read, but it's very beautifully mathematically organized. It's a book called Infinite Powers. This book by Stephen Strogatz, Infinite Powers, is a story of calculus. Stephen Strogatz is a world-leading applied mathematician. Is one of the world leaders in the mathematics of social networks, and he is also a world expert uh, on calculus. You should read the book because it shows you that how much understanding you need to have on the analytic or all the conceptual issues if you want to just do applications. So, and he shows at where calculus goes and applies, and he also talks about the basic concepts in much more detail, starting from the days of how Archimedes tried to find the area of a circle to the present time. So, police officer, I think that it's not a very good way to give a false name. I think nobody's name can be police officer. I will not entertain such questions. Uh, Police officer, where I am telling he's writing, I have Casio 9111X, then somebody is writing, oh, no more books, please. This police officer, I think he should reveal his own name. When you come to a course, this is an honest course. This is not a nonsense which is going on. So it's a course given from a good institute. So I think it's honest. If I am honestly telling my own name, you should be honestly revealing your own name. There's a question on the paper here. Manoj Dan is asking how to deal with differentiability problems by using epsilon delta concept. How to deal with graphical representation of functions. Differentiability problems by epsilon delta concepts. Differentiability, what did I just tell you is that if derivative is a name given to a special kind of limit. So you know that derivative of the form y with respect to x is limit of delta y by delta x as delta x tends to 0. So this value, this quotient delta y by delta x has this as the limit. And you know what is the definition of a limit. And you know what is the definition of a limit. So that is how you would express the whole thing. Right? That is how you express the whole thing you can write down the whole thing in terms of epsilon and delta. Okay, and
So Newton's approach for
if you want, I'll tell you. If you want to write the whole thing as a limit, so given epsilon greater than 0, there exists such that there exists a punctured neighborhood of H such that, so I am writing the definition of the derivative x plus h minus f of x phi h minus f dash x. This should be less than epsilon. Delta greater than 0. So that this is true whenever that is how you write in this term. This whole thing is the limit, this derivative in terms of an epsilon delta formulation. So you can also write it in this form if you want. If you that divided by h. So this is less than epsilon. You can write it like this also if you want it. Or so you can put it in several forms. This is also another form. So this is the basic form. Okay. So is KH integral method valid for complex analysis? This is something I really have to figure out. I also don't know. I have only seen it for real functions. I have not really learned, really know anything about complex analysis. If you are interested, then let me know through email. I'll just check it out. Now another thing that somebody has asked me, Gayatri Dumka, what is the best way to learn real analysis in higher studies? The best way to learn is actually reading yourself and solving problems. So there's no other way to do. Actually, you have to solve problems. Take a book like Bartley and Shewart and go on solving the problems. Or take a book like Rudin. If you find Rudin harder, I think you should go for Bartley and Shewart, this book which I mentioned. And then you should actually try to solve the problems given in Bartley and Shewart. There is no better way to do things. You have to solve the problem because that will give an understanding of which idea you have to apply where.
Sir, Amit Kumar has asked Newton's approach for integrals.
Newton. See, Amit, you have to understand that the approach of summing up. What is the meaning of integration? You take the whole thing, you sum up into small parts. You calculate on the small parts, and you the whole thing, break it up into small parts. You do some operation on a small part, and then sum it up. So that is what integration is. That is what is sometimes called by Steve Stovach has called it the infinity principle. Let me tell you one thing. The calculus of Newton is based on continuous functions. But here in Riemann's case, he is talking about bounded functions. Bounded functions need not be continuous. For example, in a Newton's theory, Newton is never talking about, say, step functions, where there is a discontinuity here. So, say between 0 and say 4, something like this, or 0 and 3. This is the function. I want to integrate between 0 and 3. And Newton's theory cannot tell me anything about it. Newton's idea of integration is not telling me anything about this. But Riemann's theory says that yes, we can integrate, we can talk about the area under such functions. See, when you are talking about integration, please understand just don't think that area integration simply means area under a curve. Area under a non-negative curve, for a curve which is non-negative over the given zone of integration, then we can say that integration refers to the area. But if it is not, if it is taking both negative and positive values, we cannot say it is talking about an area. Please understand that. Cauchy principal value gives integral values under limiting condition, while area in general is different from the former. Then why we use it to find? See, sometimes Cauchy principal values, people are happy to have a Cauchy principal value. Sometimes some integrals, especially in applications in engineering, they would like to have a number for that integral. So then Cauchy principal value is sometimes used. I do not understand when you say this Gayatri Dunka has just asked, I am not able to solve questions of real analysis which are of theoretical nature. You tell me what is the difference between theoretical and practical. Can one put you a question in a textbook? I should then, to really go and solve a real life problem. There is no textbook which asks you to solve a real life problem. Textbooks are to just test your basic knowledge. If you are not happy with Bartlett and Shepard, I think you should go and look at the book by Thomas. Thomas has calculus, Thomas and Finney. In Thomas has calculus, there are a lot of things where you really have to build a model, do a computation, and then find an answer and interpret the answer. So those are small problems. You don't have real life engineering problems being put in your calculus book and you are going to solve it. If it was that simple, then they would have no reason to make engineering a separate discipline, or economics a separate discipline, or physics a separate discipline. So please understand that most books, I don't understand this. People ask me, what is the difference between theoretical problems and practical problems? If I give you a little bit of application oriented problem, that becomes a practical problem. And if I don't talk about applications, you think that, okay, this is something theoretical, uninteresting. Please understand that theory and application is linked. There is no way I can say that a theoretical problem is important and a practical problem is not, or vice versa. Only I should bother about practical problems. Anything which doesn't come in real life should not be put in textbooks. Please understand that your Newton's laws of motion, your whole physics is based on idealistic formulation of the real world. Real world is not exactly what physics books tells you to be. So please understand, mathematics is used to model things in reality. It doesn't exactly capture reality. Modeling, mathematical modeling is part reality, part fantasy, and that has to be accepted. If you accept that thing, then you progress in science. You will see a lot of, if you look at Galileo's results, a lot of results on inclined planes are done without friction, because you can polish the plane so much that the friction decreases. So you really study what happens if the friction was not there. So you're studying a kind of limiting condition. In science, you really focus on the essential and you take out the inessential. So science doesn't capture each and every complexity. A mathematical model doesn't capture complexity. Mathematical model is to look at the simple situation, more idealistic situation, in an absolutely unambiguous and coherent way. Ram Gopal Shaini, I want to learning calculus, or I want to learn calculus. Okay, you want to learn calculus, then you should go through this course, I would say, or any course that you find on the net, or have a book. Zahir Hussain, on reparameterization of curve. Reparameterization of curve? Okay. Parameterization of a curve. So if you have a function like, so if you have our circle, so if you have a circle of this form, x square plus y square equal to r square. So you can write it in terms of polar coordinates. So I have parameterized with respect to r and theta. So that's parameterization. Or if you, for example, you have y square equal to 4ax, is a parabola. This is the graph of y square equal to 4x. This doesn't represent a function. So x equal to 80. Then you can take a parameter t.
Y equals to t, then x equals to t square by 4.
So x is equal to 280 and y equal to
X equals to 80, y equals to plus minus 280.
x equal to no. So I'm just trying to parameterize it. So basically I have to put x as a function of t when I put this, and what I have is y square should be I have to put y also as some function of t when I square it, and I put x also in that same way, it will come. So x equal to 80, y equal to 280 square. If y is equal to 280, then y square is equal to 4a t square. So if y is 280, x is, so if I have to just take x equal to t square. So x equal to t square and y equal to 280. Because if I square this, it is giving me 4a square t square. So x equal to, so 4a square t square, 4a into 80 square. So if I take x, y equal to 280, and y square is 4a square t square. Okay. Now this 4a square t square means 4a of this 4a, a t square. So these I can take as x. So x can I write as at square, and y I can write as 2at. So this is called the parameterization of the parabola. So when I put y square and I put x there, then both sides matches. So this is called the parameterization of the parabola. X equal to 80, y equal to 2, x equal to 80 square and y equal to 280. Okay, Tunushi, have a look at it. That's the parameterization. So how to draw the graph of f dash x from fx of a given function? I really don't know. Maybe you should tell me if you know it. Because f dash x again is a function of x, I'll just draw the graph of f dash x. By knowing just fx, how, and without knowing f dash x, I don't know how can I draw the graph of, how can I draw the graph of, I don't know, my mathematics is much weak in that sense.
That angle, then tan theta, then only we get gradient, right?
No, I don't understand. He might be telling that, okay, why don't you keep on drawing the tangents? So if you keep on drawing the tangent, you get back the graph of the function itself. You
No,
don't get back.
actually-
That is what they're in the mind of the question maker, Gaurav Vyas. But please understand, f dash x is a function of x.
I think one similar question was.
For example, I tell you, you take y here. I'll take this y equal to x cube, and y equal to y dash. Y dash is 3x square. The graphs look completely different. I do not know how would you draw the graph of 3x square from the graph of x cube. X cube looks like this, and 3x square looks like something like this. Sorry, 3x square looks 3x square would look something like this.
You got that one.
I'm sorry, I'm making. So this will be x cube and this x square, something like this, and they'll cut at 1 and go on. Cut at 3 or something like that. Something like this. So how can I draw these two graphs? The two graphs are totally different. You take y square y equal to x square. Look at the graph of y equal to x square as a parabola, and y dash is 2x. It's a straight line having both positive and negative values. And f doesn't have positive and negative values, has only positive values. I do not know. If you know something, you can teach me. I'm happy to learn from you. Yes, I'm putting this mobile on silent. It's not a good idea. My question is for error bound for Simpson rule. Error bound for Simpson rule, it cannot be told right away. I have to really get a book to talk to you about the error bound for Simpson's rule. I really have to get a textbook to tell you error bound for Simpson's rule. Amit Kumar, how can we make a partition in case of piecewise continuous function and discontinuities, especially while solving integrals using Riemann sum? How Riemann sum is defined as discontinuities. See, the idea is very simple. You take two different intervals, partition one of them, do the integral on this part, do the integral on that part, and do it. That's the kind of thing that he talks about. Okay, what you that's the practical way of thinking about it. But when you do a partitioning or an integral, suppose you want to do this as a whole, it doesn't matter. It doesn't matter. Even a discontinuity part can be on a partition, but you know at what is the function, what is the function value there. But discontinuity point, there is a function value. So at every point in that thing, what are we doing? We are finding the upper Riemann sum and the lower Riemann sum. At that, when we are trying to find a Riemann integral at every interval, maybe I am talking about this interval. What I'm trying to find? What is the infimum value here and what is the supremum value here? The supremum value, suppose here it takes this value and doesn't take this value. But this, say this is 1 and this is 2. So 2 is the supremum value and 1 is the infimum value. So the Riemann, the notion of this, please understand, in case of Newton's integral, he was just doing a partition, taking any point there, any point in between in that partition and calculating the function value at that point. But please understand, even if a function is discontinuous, it has a function value at every point. Please understand, I am talking about a function which is bounded. I cannot integrate, suppose this function was like this. With this part at this point, this part is going towards infinity. This is just going towards infinity. Then I cannot integrate it by Riemann integral because the function becomes unbounded. The function has to be bounded below and function has to be bounded above. So then those functions can be integrated in the Riemann sense. Please understand, in this case of discontinuities in the Riemann integral, we are talking about finite discontinuities, a jump discontinuity. So at every point there is a functional value. Maybe there is a discontinuity at that point, but there is a functional value. That the functional value at this point, the left limit and the right limit doesn't match. That's the issue. Because the right limit of the function value and left limit of the function value doesn't match. So there is a gap. So the continuity is not there. But there is a function value at that point. So we just have to take an interval and look at which is the maximum value at that interval and which is the minimum value at the interval, because the function is bounded over the whole interval. So over the small partition also it is bounded. So that's the whole meaning, that you did not bother about Gayatri. You are talking about how can you see uniform continuity through a graph. You cannot see uniform continuity through a graph. Nobody bothers about uniform continuity much in practice. If whenever you have a function, continuous function, if you define it over a closed interval, it is always uniformly continuous. This is the result. So this is the power of mathematics, that it gives you a result so immensely beautiful that if you have a closed interval and if you have a continuous function defined over it, then that is always uniformly continuous. So once I do that, I know it is uniformly continuous. And that is the only practical way to look at the graph and say, okay, it is defined over a closed interval, so and a continuous function, so it is uniformly continuous. There is no way looking at a graph and say a function is uniformly continuous. What is uniform continuity? What is uniform continuity? Uniform continuity means what happens in continuity? When you are talking about continuity, we are talking about continuity at a given point, say x naught. So what do you do, given epsilon greater than 0, there exists a delta which actually depends, which is greater than, which is a function of both the choice epsilon and also the chosen point x naught, such that mod of fx minus fx naught is less than epsilon whenever so now if I change the x naught and keep my epsilon fixed, this delta will change. If I change my epsilon and keep, in general, my delta will change. Now what happens if it doesn't matter if I keep an epsilon and if I can find a delta for such that for whatever x naught you choose, it doesn't matter, the same delta will work. The same delta will work. Whatever x naught you choose, it doesn't matter, the same, for once my epsilon is fixed, the same delta will work for all the epsilons. If you can find such a delta, then we said that the thing is uniformly continuous. Uniformly continuous in the sense that once my epsilon is fixed, I can find the same delta will work for all the points. When I remove the dependence of delta on the x naught, my chosen point, then we said that the function is uniformly continuous. But please understand, if you change epsilon, delta will keep on changing. The uniform continuity is based on the idea of the point, that it doesn't matter which point you are looking at, this same delta will work for this given epsilon. What happens? You take, suppose you are looking at continuity of function over a small interval. At every point you find, for every point you fix an epsilon, but for every point x naught you find a delta. And you take the infimum of all those deltas. Basically, you take infimum of all those deltas for a fixed epsilon. Delta x, and x is over some interval AB. If this interval, this is strictly bigger than 0, this one, this infimum, then this delta will work for everyone. This delta will then work for all possible x naught. That's the idea. So this delta will then work for every possible x naught. So if suppose the delta that I use for x naught is bigger than the delta that I use for x1, then I can use the one which I use for x1 for both x0 and x1. So in that way, if I take, so I keep on decreasing my delta. So if the infimum of all such deltas is strictly bigger than 0, that particular delta will work for all x in AB for this particular choice of epsilon. Please understand, in a uniform continuity, epsilon is first fixed, and we are talking about whether delta's choice of delta depends on the choice of x now. It will definitely depend on the choice of epsilon, which you cannot remove. But I can remove, can I remove its dependence on x? Actually, if it is on the closed interval, then I can remove, this is always true, I can always remove its dependence on x. That's the idea. So if you have a delta which is working for x naught, given an epsilon, if the epsilon is fixed, and another delta which works for x1, suppose that delta is smaller than the delta that works for x naught, then that smaller delta will also work for x naught. Then that smaller delta will also work for x naught, because delta means what? You have an x naught here, you have a one. So you would look at, so basically what I am telling you, suppose you have an x1, and for that you have a particular delta 1, and for x naught you have delta naught, but delta 1 is supposedly less than delta naught. It is of smaller radius. So x minus x naught, if it is strictly less than delta 1, if I take only those points, is also strictly less than delta naught. So the delta 1 that works for x1 for the given epsilon will also work for delta naught, will also work for x naught, because delta 1 is smaller than delta naught. So if I just only consider those x minus x naught which is less than delta 1, that will also work, that will also, for those x's will also give me this result, because those x's are within x minus x naught less than delta, it is within the delta neighborhood. So if delta 1 is smaller than delta naught, the delta 1 neighborhood around x naught is within the delta neighborhood. So whatever is happening in the delta naught neighborhood will happen in the delta 1 neighborhood. So if I have smaller and smaller neighborhoods, when smaller and smaller neighborhoods, whatever has been working for the earlier points now will also work for the earlier points. So hence, if I get, finally, if I take the infimum over all the deltas, and if this is greater than 0, then this will actually work for all the x's for a given epsilon, and that will be always true on a closed interval. That is the beautiful thing. Laplace transformation is an improper integral. I'm not here to teach you Laplace transformation. This is not a part of the syllabus, but okay, if you're asking me. So it's f of or f of s, L of s. So this is the Laplace. Given a function f, this is the Laplace transformation of f. Now you have to find conditions under which this integral is convergent. This is an improper integral, and then you compute it depending on what is your structure of f. So this is your Laplace transformation. So obviously Laplace transformation itself is defined through an integral. So Laplace transformation has to be related to integration, but it is an improper integral. It's very surprising that this question has been asked by someone, because if you know what Laplace transformation is, then you don't ask this question, because if you know the definition of Laplace transform, then you must have seen that it is defined through an integral. How to prove that sup of f plus g is less than sup of f plus sup of g? So will you prove it for me? So my TA will prove this for you. I'll just take a little bit of rest. Dr. Tanushree Pandit will prove this for you. This is a very simple question.
Okay.
I need brown sugar. You know brown sugar.
I'll get it.
Where you have it?
No, sir. I'll get it. I'll go there.
You don't have to go there.
Here it is not there.
Okay, so first let us see that what is a plus g. The function a plus g is defined in this way. That ax plus gx. So now you know that a plus g at any point x can be written as fx plus gx. So this will be always less than equals to supremum of f. Right? If I just consider this part, then fx is always less than equals to supremum of f. So plus gx, this is always true. Again, you can write the same way that now this is the constant part. This is independent of x, and this part is only depending on x. So you can write it as supremum of f plus supremum of g. So now you see that for any x, f plus g at x is
So
less than
sup f plus sup g becomes an upper bound to the function values f plus gx. So the supremum of which supremum means the least upper bound. The supremum of f plus gx must be less than the given upper bound. Least upper bound must be less than any upper bound.
So this is a constant term. This is independent of x. So this will give you that supremum of this function f plus g. This will be less than equals to supremum of f plus supremum of g.
Okay. So Gayatri asks a question: in sequence and series of functions, is there any graphical way to check uniform convergence of function? Or graphing a sequence is not a very good idea. You really don't get much idea of looking at the graph of a sequence, because you really have to continue doing it till the infinite part, and you won't understand much about how the sequences behave here. If it is a convergent sequence, you will have some idea, but uniform convergence you cannot check. Again, I think your question really relates largely to uniform convergence. But again, uniform convergence is what? It's essentially, again, the story comes when you talk about uniform convergence of a sequence of functions, not a sequence. Then essentially it is again, you know, when you have a sequence of function, what is uniform convergence of a sequence of functions? So if you have fnx here, right? So fn, so that is it. So we, when we say fn goes to f, so it is a sequence of function going to f. What we mean is that fn of x goes to fx for all x. So now give me an epsilon greater than 0. So I choose a x for my given x, for a given x. Given an epsilon greater than 0, there exists a delta greater than 0 such that, sorry, there is a, not delta, there exists a, given epsilon greater than 0, there exists a n, or maybe how should I write it, n hat, element of the set of natural numbers, such that fnx minus fx is strictly less than epsilon for all n, this small n index, frequency index n, bigger than or equal to n hat. So whenever n is bigger than n hat, that is except a finite number of terms, the difference between fnx and fx, this difference, more absolute value of this difference is less than epsilon. This is, so once I know the x, I am just writing down the convergence of this numerical sequence of real numbers fnx to fx. Now this n hat that you see, this n hat actually depends on the choice of both epsilon and the choice of x that you take. See, if I fix my epsilon and I keep changing the x's, this n hat will keep on changing. Uniform continuity of this sequence of function means that how can I take away the dependence of n hat on this x? When once I have fixed an epsilon greater than 0, it doesn't matter. Given an epsilon, the same n hat will work for all the x. That is called uniform convergence. So what is the relation between upper sum and lower sum to the maxima and minima of functions, which is Riemann integrable? I am sure you have not listened to the lecture very carefully. These questions should not be asked. Sometimes some questions are coming which are just, you want to ask something. These questions on uniform convergence is fine because many people might not understand this idea of uniform convergence. This is a good question by Gayatri. These are good questions to ask about uniform question in convergence, but asking about the Riemann integration. You see, in Riemann integration, we have first take a function from a to ab to r. We do not say whether it is continuous, but we only say it is bounded. That is, there is a supremum and an infimum. So we say fx is lying between the supremum, which is m, and the infimum, which is small of m. Okay. And the relation between these two are the following. So integral a to b fx dx has to be less than m of b minus a and has to be bigger than small m of b minus a. Use the definition of the Riemann integral from the lecture and figure this out yourself. This is I have done this in the class. I remember. I'm sure I've done this in the class. This comes from basic definition. Not sure.
He again had to go. He's forgotten. He had to go to CCD. You need to wait.
Okay.
Are you done?
I don't know. No more questions at this moment. Here I have answered what Laude Ujju types of calculus. Of course, there are two types of calculus. There is one calculus, but people have two types: differential calculus and integral calculus. I do not know if is there any other type of calculus. You can educate me on that. I do not have any other question coming at this moment.
So can we conclude, sir, in that case? Can we wind up, sir? Or
So that's
can we
up to
also
you.
pause?
It depends on the time frame.
Sure, sir. Sure, sir. So would you like to wish them for their examination, sir?
I'm just waiting for one question. Maybe if there's no question, then.
No, it was 5 to 6, so they will not pose any more questions. You wish them good luck and say bye bye.
Okay, I wish you guys good luck, all the young minds. I have one thing to tell you. Mathematics is a very natural thing. When you read it, don't read it with a kind of feeling कि ये तो मुझे पढ़ लेना है, कैसे भी exam दे देना है. It's not the way. And if you cannot do a proof now, that's not your fault because you have not been uh, part of this whole game of how mathematical proofs are done. They are not done at school. It's not your fault. But try to reason out things. If you can reason out in real life, you can also reason out in mathematics. It's the same logic that you want to apply in real life, and the same kind of logic applies in mathematics. You have to be a little patient. If you cannot do a problem, if a problem takes half an hour of your time, don't get worried. Problems are not, we do not know how long a problem needs to be solved. It can take 5 minutes, it can take 20 minutes, it can take 2 days. Even if it takes 2 days, just persist with it. Okay, Avinash Rai, your question has a limit between 2 and 3. So E comes that E is taken as that this limit of this is E, it is between 2 and 3. How can be calculated as E value? So you have to know that E is an irrational number. So all calculations that are done are done through the series of E, and those are actually approximations, rational approximations. And I unfortunately have no time to talk on details about this issue now because time is over. So it's an irrational number. All the number that 2.718 that numbers values that you see of E is essentially a rational approximation to this number. So again, best of luck. So when you prepare with a cool mind. You don't have to worry even if you do not know things. It is much better to live with ignorance than to have answers which might be wrong. The spirit of science is not to always know things. Spirit of science is to ask good questions, and that is what I want to tell you at the end. Thank you.
Yeah. Thank you, sir.
There.
Wrong sheet is not there. This is it.